Hello, Karthik. I'm back. So people can type their questions on the live
Hi, Vani.
chat. We should be able to see them and I can answer yourself as well. Okay. So 1 more minute to go, but not people have still joined. Okay. 18 are watching now. We'll probably give a couple of minutes, Karthik,
Sure, Balaji. Yeah,
and I'll do a quick introduction. Then you can take it from there.
sure, Balaji. Yeah, thanks.
Right. Right. It's 1 minute past. Karthik, are we good to start? Can I do a quick intro?
Yes, it's Balaji.
Right.
Yeah,
Yes. Welcome everyone to the 19th DevOps Meetup. Sorry we have to do it online this time. The reason being we were focusing heavy weather again. We meant to be happening it last Friday. Because of heavy rain, we postponed to this Friday, and we don't want to postpone again. And Karthik also has to be away for a while. So thanks, Karthik, for squeezing your time to do this presentation. Karthik is from AstraZeneca. He works for the Chief Technology Office, the CTO office. So this is going to be a series of talks on Kubernetes, the orchestration platform. Karthik will do the basic one today, and we'll have more sessions in the coming meetups. Um, Thanks very much, Karthik, and over to you.
thanks, Balaji. Thank you, everyone, for joining us. I'm Karthik, working for CTO, as Balaji told. So this will be a series of events on Kubernetes. Today, I'll just give you an overview on what's Kubernetes, how we can use, and all those things. And the next session will have a demo on that. Is about use cases, scenarios, and questions, and whatever you have. So without wasting much time, I'll just get started. So Kubernetes. So Kubernetes is the buzzword these days, I would say. It has come a long way. If you would have seen, like, a lot of people are interested in adopting Kubernetes. Past me, like a year back, a lot of people would have, been thinking why we should use Kubernetes, what does it offer, and all those things. Because uh, a year back, a lot of people were really thinking whether to adopt containers at the first place, and then adopt for a orchestration tool like Kubernetes. So Kubernetes, as you all know, it's a Google product. It's open source and it can be used. So why Kubernetes in the first place? That's the big question these days, right? So what people are doing is, like, they adopt the containers as the picture shows in the presentation that I'm sharing now. A lot of people are interested in adopting the, so they're really unsure whether to go ahead with container technology until production, because they are really comfortable with the non-production environment. But when it comes to production, they really think twice before adopting this container technology, because you can easily lose the containers that you have created, which might end up in serious business trouble. So that's the main reason why we need a tool like Kubernetes, which really does a good orchestration on all your containers that you have implemented or deployed or whatever it is. So when the container technology took over the industry by storm, people were really thinking of a tool like Kubernetes, which would help them organize everything collective, and which can be easily maintained even in a very high complex projects. So Google, they were using it for a long time, and then they released it as an open source project. So when the container technology took over, and Kubernetes was the best orchestration tool that was available in the market. So that was the main reason why people were starting to use the Kubernetes tool. So as I told you, if you could see the previous slide and the next slide, there's a lot of difference that the picture speaks for itself. So if you could see the previous slide, the containers are scattered, you don't know what is where, and it's very difficult to maintain all those things. If you could see the next one, it's easily identifiable. You can easily identify which container is for what and all those things. This is the main job that Kubernetes does. That's the power of Kubernetes, I would say. It is well organized, and it can be used for any complex container technology that you're going to adopt or is being adopted. So apart from that, Kubernetes offers a lot of features that you can use, that I'll be covering in the upcoming sessions, or today I'll give you an overview on what are all the features that they are providing with Kubernetes. There are a lot of features that even we haven't explored as of now, that we are trying to explore in the future. So that's the amount of features that Kubernetes offers today. So moving on, I would say the state of the project, as I told you, like a year back or a couple of years back, people were really hesitant on to whether to adopt Kubernetes. But if you could look at Kubernetes, it has come a long way. It has beaten everybody. It has beaten all its competitors. A lot of people are adopting it. The number speaks for itself. I didn't share the numbers today in the slide because you can see it in Google or anywhere. The state of the project is that there are like 50,000 commits that have been uh, pushed to the Git repo that Kubernetes offers, but they don't have the master repo publicly open. They have like special interest groups. So those special interest groups have various developers who develop their own feature and push it to the open source community. So that's the state of the project with Kubernetes. And if you could see the adoption has been, a lot of people are trying to adopt Kubernetes these days. I could hear a lot of people coming to us within AstraZeneca itself, outside, like many other companies who I've worked earlier. They have been in touch with me about Kubernetes. They are really trying to adopt it because it is it is very, very easy to adopt it. It's flexible, and even if you have a complex project, you can adopt it. That's the main reason why people are looking for Kubernetes. So moving on, I would say, like, um, it's very much uh, flexible when you go ahead with the cloud providers. So when you have a cloud provider, when you're adopting cloud providers, Kubernetes comes out of the box for GCE and AWS particularly. Though it supports all the other cloud providers, GCE and AWS support is numerous, and a lot of people are working on the features that AWS and GCE could offer. So though it offers a lot of support for a lot of cloud providers, AWS and GCE, they remain on top of all the other cloud providers. So when you look at the Kubernetes project itself, um, since it's a Google product, it comes out of the box with GCE, the Google Cloud Compute Engine. But AWS, there was a recent survey where, I mean, recent talk about AWS moving out of contributing to Kubernetes and all those things. It'll be a huge loss for AWS cloud provider as well as for Kubernetes users as well. That's the power of Kubernetes these days, because a lot of people have started adopting, or they've already adopted the Kubernetes project. So moving on, as I told you, the adoption, as the picture speaks for itself, there are a lot of people who are interested, or are trying to use, or they're doing a proof of concept these days. I would say the number of Kubernetes users within the community will certainly increase over the years, because the support that they provide is very good. The features, and you could see there is a release every couple of months at least, though it's like 45 days or 2 months. I would say a good number of releases every year with a lot of features on security. There was a security feature RBAC enabled with recent releases with Kubernetes, which is so cool to use. And if somebody is looking for a secure platform, then that's the version that you'll have to use. So lot many features have been explored and experimented and pushed to the latest releases. So that's the main reason why the adoption increases everywhere. And between, if you have any questions anywhere, you can just stop me, or you can type a comment. I'll reply back. So moving on, the architecture. So the main part of Kubernetes is the architecture in itself. So the one that I'm sharing uh, is the multi-master architecture of Kubernetes. Multi-master, the name speaks for itself. It has a number of masters. It's up to you to configure how many masters you want. The main reason for Kubernetes to release this multi-master architecture is to have the high availability. Earlier, there was a single master cluster alone until the releases up to 1.4 or 1.5. So they were having only one master with number of nodes where they were uh, implementing all their features. But due to various reasons and high availability with zero runtime, all these parameters when they were taken into account for large projects, so that's when they came up with this multi-master architecture. So if you could look at the architecture that I've shared, there's a load balancer. Prior to that, there's a client that you could access. So this load balancer will always take you to through the client that you're accessing, whether it's a kubectl or any other client that you're going to access. Load balancer, the load balancer in turn hits the masters. So there are like 3 masters that I've shared in the picture, but it could be 2 or 4 or whatever you want based on your requirement. For each master, there are a lot of components that they use within the architecture itself. One is the API server, which is the main thing, because the API server is the component that's going to hit the Kubernetes API, that's going to expose the whole of Kubernetes API to you. And the next one is the data store, which is etcd, because all your cluster data in the master is made available in this etcd. For instance, etcd, as you all know, it's a key value pair data store. It's strong, it is consistent, and it is highly available. So all these components that I'm going to explain are made available in each of the master nodes. Okay, so moving on, like the next one is the scheduler. As the name else, like scheduler is used to schedule all the pods to specific nodes, be it a master node or a worker node. So earlier there was a concept in Kubernetes which tells like the masters are called masters and the nodes are called minions. We no longer call it as master and minions. Now it's called master node and the worker node. That's how it works now. And the scheduler, as I told you, it's going to schedule all the pods into the nodes. I'll explain what is a node, what is a master node, what is a pod, everything in the upcoming slides. And the controller manager, there are 2 types of controller managers. One is the kube controller manager and the other one is the cloud controller manager. As I told you, the kube controller manager, it's to control all the activities of the Kubernetes cluster. And the cloud controller manager, it is used to maintain the cloud service provider data, interaction with the cloud service provider, and all those things. And then comes the kubelet and monet. So kubelet is nothing but the node agent which takes care of all the activities that a node performs. And this pod master, this is no longer being used now, though it needs to be removed. I've just added it here. Earlier they were using to this pod master so that it acts as the leader to all the pods in the master node. And moving on, the monet is also another component that is used in the master node to monitor and monitor all the activities that a master node is going to offer, or it's going to provide you. So all these load balancers, all these three master nodes are accessed via a load balancer. There are a lot of complexities, because when you lose one of the master, it's still going to be available on the other masters. But sometimes when you go and do it manually, when you're trying to delete one of the master nodes manually, you'll have to be very, very careful, because you can easily lose the data, or your route 53 entry or any of the network entry may not be updated properly, or it may be corrupted. So though the architecture is, you'll have to be very, very careful while performing administrative options with the master nodes. So coming to the worker nodes, as I told you, the master nodes, you're not going to host any of the application related pods or nodes or whatever you want, because it is for the master components. But still, the scheduler can deploy all the pods or nodes to master nodes if you have a specification in your YAML files. So Kubernetes, it is going to use the YAML files to deploy all the features or application, whatever you're trying to do. So worker nodes, as I told you, you can have n number of worker nodes based on your cloud provider. Say for example, if you're using a AWS or GCE, there's a feature called cluster autoscaler, wherein you can just define 3 worker nodes in the starting. When your application load increases, you can have a specification in a cluster autoscaler, so that the worker nodes get increased automatically. When the load decreases, the worker node decreases automatically. So you can maintain the high availability, as well as you can scale at will. That's the main feature of cluster autoscaler. So that is one of the feature that Kubernetes offers. So moving on, as I told you, the features, it's self-healing. That's the main feature that Kubernetes offers. Say for example, if you're going to lose a container or a pod, it's going to come back again. So it is, the Kubernetes project in itself is so very powerful that it is going to heal it itself. If you are going to delete a master node, for instance, by mistake or something, it's going to come back again. So it's going to come back again with a different IP or any other thing that's configured as per your requirement. So self-healing is the main concept that Kubernetes offers. Say for example, if you're going to delete a pod or anything which is replicatable, it's definitely going to heal it itself. That's the power of Kubernetes. Auto scaling, as I told you, it's an important feature that everybody are looking for. Say for example, if there is a user in your application, and the users grow in the future, you never know how many nodes you'll have to use for your architecture. So what you can do is, like, you can have a minimum scale and a maximum scale. Say for example, each node is definitely an instance. Say for example, if it is an AWS instance, it is going to be an EC2 instance, and if it is GCE, it's going to be an instance, and physical servers, it's going to be a server. So if you have minimum scale, and you can define a maximum scale, and the scaling is very much automatic. So you'll have to just run the cluster autoscaler utility, and it's going to take care of everything. There's a very neat log that is maintained, which tells what is happening in each of the nodes, each of the pods, when it's going to scale up, when it's going to scale down. All the features are recorded. So it's another feature that Kubernetes offers that everybody are looking for, because when you start your project, you're not sure how many users will hit your application, and you need not worry about scaling in the future. So auto scaling is an important concept that Kubernetes offers. So similar to auto scaling, the rollback and the rollouts are also automated. So there is a concept called rolling update. You do not have a downtime for your applications. You can always do a rolling update, which means you can update the application with the upgraded version. You can deploy it, and then you can remove the existing version. That's what the Kubernetes is going to do. That is what is automated rollout is all about. Rolling update is an important feature that Kubernetes offers. I'll explain it to you in the demo very clearly about the automatic rollouts. It's an important concept if you are trying for a zero downtime service. So that is about the automated rollouts. and as well as the automated rollouts, there is similar technology for rollback as well. Any deployment that we are going to perform as a DevOps person or a DevOps engineer, rollback is very, very important. It's going to do it automatically for us. That's another important feature that Kubernetes offers. So storage again, network and storage are two important aspects that everybody looks out for when you're developing an application. So storage is very well orchestrated, because if you could see the self-healing and auto-scaling and automated rollouts, every one of the feature, it's going to either delete the pod or bring up a pod or bring up a node or whatever it is. But what happens if it's going to scale down? What happens if a pod goes off? What happens if you're coming up with a new pod? Storage is very, very important. Unless and until it's very well orchestrated, it is very difficult to manage. But Kubernetes offers a very good storage orchestration with persistent volumes and persistent volume claims. So persistent volumes is nothing but the storage that you are going to specify it, where that this much amount of volume needs to be attached to so and so volume. So that persistent volume can be claimed by the user of the application. Say for example, you have n number of application, you can have n number of persistent volumes and n number of persistent volume claims. So even within the Kubernetes cluster, you can have n number of internal clusters in itself. Say for example, you can have a shared cluster for all of your applications. If you're a DevOps team and you're managing many different applications, say for example like 10 applications, you can have each one of them as a single cluster, so that it is very well orchestrated. I'll show that in the demo that I'm going to do. And the batch execution is nothing but everything is executed in batches. So all the master data, the cluster data, or whatever the components or features that is being performed by Kubernetes, everything is executed in a batch. So there is a minimal lack of missing the minimum amount of risk that you're going to take. So that is one of the biggest options. And automatic bin packing and secret and configuration management, those are also the features that everybody is looking for. So what happens is like Kubernetes decouples the configuration data and the Docker image that you're going to do, because it is very, very tedious to maintain the images with the configuration data. That's why Kubernetes is very powerful. Secrets, it's going to maintain all your classified data or the configuration data that you're going to maintain. And the images are made available in the pods or replication controllers or deployments, whatever you're going to use. So one of the main features that Kubernetes offers. So any questions or concerns or doubts so far?
Karthik, to see the questions, go to this URL. I will ping you the URL. It's in the live channel. Once you go there, please ensure
Okay.
you mute that audio from it. But so there's no question so far yet. But it's good to have a pause like that. Karthik, are you speaking? Karthik, I think you are on mute. Oh, good. Karthik, we can't hear you.
Sorry, Balaji, I was in mute.
Okay.
I
Okay.
was talking on mute. Sorry about
Okay. Yep. No worries.
that. Okay, so moving on from the features. Meanwhile, if you have any questions, you can ask me directly or you can post it out. We'll answer it later during the session. And moving out of the features and moving on, I would say we'll go with the master components. So as I explained it to you earlier, there are a lot of master components that are made available. So I've handpicked out most of them which are being used, and I've left out few which are never being used. So the first one is the Kubernetes API server. So Kube API server is nothing but the utility in the master, which is going to expose the Kubernetes API itself. The Kubernetes API is going to offer all the features. Say, for example, if I'll just check if I have a cluster ready so that it will be easier for me to explain. So Kube API server, it's going to expose the Kubernetes API itself. So the API offers all the features that have been explained previously. And moving on, etcd, as I told you earlier, it's a strong, consistent, powerful, and highly available key value pair. That's the main thing here. Key value pair data store where all your cluster data is being stored. So for each node that you're going to create, for each of the master node that you're going to create, there is a etcd server that's going to be created, and it's going to maintain all the cluster data in there. So it'll have events, logs, everything maintained, very well maintained. So etcd, if you are going to take a backup of a cluster or anything for that matter, etcd has to be handled very, very carefully. Otherwise, you are going to end up losing the data. So etcd is the important master component which is going to store all your data, which are accumulated over time. So as I told you, there is a controller manager, and there are two different types of controller manager. One is the Kube controller manager, the other one is the cloud controller manager. So the Kube controller manager is nothing but the controller manager which routine tasks or any other tasks of the Kubernetes cluster itself. So there is a node controller, there's a replication controller, there's a token controller, there's a secret controller, there's a deployment controller. So each of them controls the activity of each of the utility that you're going to use. Say, for example, the node controller will be responsible for all the activities that a node does. Bringing up a node and assigning any of the pods to the nodes, or the replication controllers hitting that node, or that node hitting the load balancer. Any of this activity is maintained by the node controller. So similar to node controller, there's a replication controller, which I'll cover in the upcoming, and similarly token controller, secret controller. So for each of the utility that Kubernetes is going to offer, there is a controller that is going to handle all the scenarios that. So all these together is being managed by this Kube control manager. That is the main controller manager for all the cluster activities that you're going to perform. Similar to the Kubernetes controller manager, there is a cloud controller manager which takes care of all the activities that you're going to perform for the cloud provider that you're going to use. Maybe it's AWS or Azure or GCE or whatever it is. So all the activities, all the interactions, say for example, cluster auto scaling or whatever it is, whatever feature you're going to use, the instances that are being brought up, every activity is tracked, monitored, maintained, and orchestrated by this cloud controller manager. So up to your network controlling, because sometimes you'll have to update the route 53 entry. Sometimes you will end up having a load balancer IP which needs to be updated frequently. It is very tedious for you to update it, go and update the route 53 record or whatever record that your cloud provider offers. So all these are automatically taken care, maintained, and made available by this cloud controller manager. So similar to cloud controller manager, there's a component called Kube scheduler. Kube scheduler is one of the important components of Kubernetes, because it is the one which is going to schedule all your pods or nodes or whatever it is. Every pod which is scheduled to a node or whatever it is being made available by this Kubernetes scheduler. This is the component that is going to schedule your pods to the nodes, or whatever it is. All the pods that you're going to deploy or develop or use is being scheduled by this Kube scheduler. This is the one which decides what are all the resources that are available. Say for example, one of the node may not have the enough CPU or memory to accommodate the pod, so it look for the other node which has the enough resources allocated, so that you can push the pod there. It doesn't matter how many pods you come up with, how many nodes you come up with, where the pod is going to be pushed. Everything is being taken care by this Kubernetes scheduler. So the next one is the add-ons. Add-ons is another concept wherein you can use all the features that I've explained earlier. Though I've only handpicked few features, there are a lot of features that Kubernetes offers. So all these features are made available as add-ons. So add-ons, I can easily come up with few examples. Say, for example, there's an add-on called external DNS for AWS. For Kubernetes. So what that external DNS does is that whenever you whenever you upgrade the cluster or delete a master node or a specific node, or when you delete a load balancer IP, it's going to automatically update the Route 53 record in
Sorry to
AWS.
disturb you, Karthi. Can you make it
Yes,
screen,
Balaji.
please?
Yeah, sure.
Yeah, if you can bring it very slow, very small. That's fine.
Okay.
Thank you. Yeah.
Sorry, Balaji. Yeah, sorry about that. So the add-ons, the external DNS add-on, it's going to update the Route 53 record automatically. So similarly, there are a lot of add-ons that are made available. One of them is Heapster. A lot of people look to get the metrics back from the cluster, because when you have a large cluster, it's very difficult to maintain all your metrics. So Heapster helps you collect all the metrics from the cluster itself. So you can use that and integrate it with any of the monitoring tool that you're going to use to monitor the metrics or any other capability that you're going to use. Similarly, there's a FluentD and all those add-ons that you can easily implement with the Kubernetes cluster. So there are n number of add-ons like this. Based on your functionality or feature request or requirement, you can select add-ons, because a few add-ons may be deprecated and maybe developed with a new name. So you'll have to decide on to which add-on you'll have to use, how you can leverage that add-on, and how you can integrate it with the cloud service provider that you're going to use, because most of the add-ons are sometimes specific only to the cloud service provider that you are going to implement. So all these parameters you'll have to take into consideration while you're trying to implement the add-ons. So moving on, like the next one is the DNS, the domain name system. It's the important thing whenever you come with a networking concept. So DNS, it has a DNS server which maintains all the DNS entries, the network capabilities, all the network traffics, and all the network policies. So there is a master component which automatically deploys the utility called DNS controller and kubedns, which is going to maintain all the network related activities that the cluster is going to perform. All the IPs that are assigned to your master nodes or the worker nodes, or any of the elastic load balancer IPs that you're going to use, the cluster IP in itself, the local cluster IP that you're going to leverage within the cluster using different namespaces. All the network related activities is maintained by this master component called DNS. So similar to DNS, we have many other components in the master itself, though it's not very well specified in the architectural diagram. There are a few others like web UI, monitoring, and cluster level logging. So though everything is accessed via client, when you hit the load balancer, there is a similar utility which can be used to bring up a nice UI to view the cluster that you're going to use. I'll just quickly show if the cluster is ready, so that it will be easier for you to understand. So yeah, the cluster is ready. Meanwhile, I'm just hitting the dashboard. So this is the web UI. It's a general purpose web UI. So this is the UI that Kubernetes offers. So I'll quickly explain all these in the next slides, or in the with the Kubernetes UI itself. So web UI and monitoring and cluster level logging. So I'll quickly finish this particular slide so that it will be easier for me to explain that. So apart from master components, even to maintain all your nodes, you have several components that are made available. So the important node components that I've specified here are like kubelet, kubeproxy, supervisor-D, and FluentD. So kubelet, it is nothing but the node agent that is going to perform all the activities of a node, from bringing up a node to assigning a pod to the node, to maintain the metrics, to calculate how many resources are how much resource the node is having, how much resource the node can handle, how much resource the node was brought up with. All these will be taken care by the kubelet component itself. So kubelet is the main node component. Node, I would say, it acts like an agent which brings up the actual node. Whatever the function that the node performs is handled by this kubelet component. So similar to kubelet, there is a component called kubeproxy, which maintains the abstraction of all your networking activities or network storage or whatever it is. Everything is maintained by this kubeproxy. And there
Excuse
are
me, Karthik, again. There's a question from Mohan
yes,
Raj asking, what
okay.
is a pod network add-ons example funnel view net?
Can you come back again, Balaji?
What is pod network add-ons?
Okay. So pod network add-on. So uh, similar to the add-ons that I specified, for all the pods that you're going to use, you can have several, just like I explained, like the external DNS. It's going to for each of the load balancer IP that you're going to hit, it's going to update the route 53 record, right? Similarly, you can maintain all your pods within a specific network. You can have an add-on for that. That's the add-on for pod network add-on. So okay, so moving on, I'll go ahead with the node components. So supervisor D, as the name suggests, it's going to control the Docker and other utilities that the Kubernetes is using. So supervisor D is mainly responsible for keeping Docker and your kubelet up and running fine. Say for example, if Docker and kubelet is not running fine, then the entire cluster is going to be in a inactive state, or you might end up hurting the cluster, so that it becomes unstable for use at all. So supervisor D, it ensures that all of your Docker and kubelet utility that is being used is up and running fine, working fine. So that's the main function that supervisor D offers. So similar to supervisor D, there's a daemon set that you can deploy in the name called fluentd. Fluentd, this can be used for your logging, be it application logs or node level logging or the cluster level logging that you're going to use. You can have this utility in each as a pod or a container in each of the nodes, so that you can get all the logs from the node itself. So this is the component is used for cluster level logging or the node level logging that you're going to use. So quickly I'll go to the dashboard that I opened. So in the dashboard, what I did was I have a local setup that is made available. You can also have that setup. I have shared the URLs that you can use to install this MiniCube. So when I give it a
Hi, Karthik. When you go to the terminal, can you zoom it, please?
sure,
So
Balaji.
you can see it quite. Thanks.
So I think this is the best I can zoom, Balaji.
Okay. Okay.
So this is the best I can zoom. Sorry about that.
Okay.
So
Yep.
MiniCube, this is a utility to bring up a local cluster. You can try it out yourself. The only thing that you'll have to have is a virtual box or a driver that is going to support the type of machine that you're going to use, Mac or Windows or Linux, whatever you're going to use. So MiniCube start. I've started the cluster. If you could see, it starts the cluster. The latest version that Kubernetes offers is 1.8.2, and 1.9.0 is there's a beta release which has been released, but the stable release is version 1.8.2. But the local cluster that I set up was 1.8.0, and similarly it fetches all the information. And once the information is done, to have a general purpose UI, I've hit a command called minikube dashboard. So that dashboard brings up a nice UI that would help me with the debugging, because people some people like using CLI, some people like using UI. So this is the UI that the command generates. And if you could see all the components that I explained are made available on the left hand side. So the first one is the cluster specific components namespace. There are three different namespaces. The naming conventions, all these things are very simple. These are all handpicked and made available in layman terms. So each namespace can be used for a can act as a separate cluster. Say for example, these are the default namespaces that the Kubernetes cluster is going to provide you. Public, it will not have anything. And kube system, it is going to have all your master components. You can find it. I've already have deployed a service, a replica set, a deployment, and a pod. So it's having all those components. And similarly, the other namespaces default. The default namespace, again, when you click on the overview, it is going to list whatever is here. I've done the same thing for the default namespace also. So it's having the hello MiniCube utility there. So you can have any namespace. Say for example, you have 10 projects, you can, each of your project can be named as a namespace, and you can maintain all those things within the namespace. Each namespace, you can have a you have a drop down here. You can just click on the namespace, and it's going to load the workload of that particular namespace alone. Say for example, if I want to go to a default namespace pod, I'll go here, click on pods. I'll see the pod here. Similarly, I have an application called Kube system. I'll go to the Kube system. I want to see the deployments that I have done here. I'll go here. Kube DNS is the deployment that is made available. So Kube DNS, as I explained you earlier, it's one of the components that master creates, so to maintain the DNS entries that the cluster comes up with. Like you can have n number of namespaces. Each namespace can be referred to the project that you're going to deploy. Say for example, if you are having 10 or 15 or any number of projects, you can have everything accumulated to a single namespace, which means you are sharing the cluster for a specific project. For n number of projects. So namespace, again, as you can term, it is nothing but a mini cluster within the cluster. So you can have everything accumulated specific to a project here. Say for example, you can have secrets listed here. There are 2 secrets that were created for this kube system namespace. Similarly, you can have the secrets created for your application. If you could go here, you can see the data. So as I told you, Kubernetes decouples the configuration data and the image itself. So the configuration data is provided here, be it the cert or the token or your namespace or the any of your environment variables, the passwords, the usernames, any of the URLs that you don't want to expose it externally. Everything can be maintained as the secrets here. So everything is accumulated for a specific namespace. So the cluster, when I come to the cluster components, the next one is the nodes. I have only one node. Similarly, if you have 3 master and 3 nodes, it's going to list all the 6 nodes here, 3 as masters and 3 as nodes. When you click on the nodes, you can easily find the UI provides you a full set of data, the allocation that has been made, the pod allocation, the CPU allocation, the memory allocation, what is the limit that this node handles. So all these data is made available with the UI itself. There's no need that you'll have to go and perform a query or something to find it out. It's always made available in the UI. Similarly, there are conditions that you can perform. You can see what are all the nodes that are assigned to this, what are all the pods that is assigned to this node. All these details are made available within the nodes component. Similarly, like there is no persistent volume because this is a local cluster. I didn't want to come up with a persistent volume. You can have a persistent volume for each of your application or each of say for example, if you have like different utilities within the application which don't share the same volume, you can have them defined here as well. So persistent volume, that's the main functionality of persistent volume. And roles, so these roles are nothing but the RBAC roles that I'm going to explain in the upcoming slides. So security feature is another important aspect for adopting Kubernetes. Since 1.6 release, you can have RBAC policies enabled so that your cluster is secure and stable. You can give only a read level access or a cluster level read access to the developer, and you can have a similar admin kind of privileges provided to the DevOps engineer. And there's a main admin which acts as like a super admin who really administers the cluster himself. So there are a lot of roles. It's nothing but the same set of roles that you're going to define, but all the resources that you want to highlight or are made available in this roles YAML. So I'll just quickly cover those as well. And storage classes, again, the network storage or the volume storage that you're going to use can be made available here. So moving on, due to time constraint, I'll be real quick. If you have any questions, please let me know. I've explained it already. Daemon set, the fluentd that I told you. So daemon set is nothing but the pods. It's a copy of a pod which is made available in all of your nodes. Say for example, you want a utility to run in all of your nodes to capture the logs. You can deploy the pods to each of the node using this daemon set. The main functionality of this daemon set is to run a copy of your pod in any of the nodes that you're going to deploy. If you are having 100 nodes, you can deploy fluentd in each of the nodes, and it's going to push the logs from each of the node to your the cloud logging tool or whatever you're going to use, your internal inbuilt logging tool or whatever it is. So that's the main functionality of daemon sets. So deployments and replication controllers are both the same. So what deployment does is, first I'll explain replication controllers, and then I'll go with deployments. So replication controllers, it's nothing but it's going to define how many number of pods you can deploy. Say for example, it's nothing but the replication that you're going to offer. If you want one of the utility in your project to have 100 pods because the load is high, and the other utility can have only one pod, the other needs to have 5 pods, you can define everything in this replication controllers. Again, when you go and see this replication controller, when I go and edit it, if you could see this replicas, I've given it as 1. So when I'm going to update it as 2, it's going to come up with another pod. See, just immediately it created another pod. So it's just 0 seconds. I'm going to pod section, just created some 6 seconds back. Similarly, when I want to scale down, I'll just go here, scale, there's another option. See, it updated to 2 replicas. I'm just bringing it back to 1. So it's going to scale down one of them. So this is the main functionality of this replication controller. You can always define the number of pods that your application want in this replication controllers. So as I told you, pods is the smallest working unit of Kubernetes. Pod is nothing but collection of one or more containers that you're going to use. So that's the main functionality that pods offer. So even pods, when you click on pods, you can easily go and find what are all the specifications that you have provided. This pod is taking the specification from the replication controller or deployment that you're going to use. So the pods can be deployed by daemon sets or deployments or jobs or replication controllers. Anything can deploy a pod, but each has several capabilities. Say for example, replication controllers, it just does the scaling up and scaling down, but deployments section, it just goes beyond replication controllers. What it does is like it's going to have a history maintained of all the deployments that you have done. You can easily roll back. There's no rollback option in replication controllers as such, but you can go ahead and roll back to a specific version when you have a deployment specific utility that you're going to create. So this is the main difference between deployments and replication controllers. But at the end of the day, everything, all the workloads, daemon sets, the deployments, the jobs, the replication controllers, everybody are going to create the pods. So pod is the smallest working unit, which is nothing but a collection of one or more containers, which handles all the application or the deployment that you're going to make. So replication controllers, similarly, you can scale up and scale down to the amount of to run for the specific utility. So deployments, this deployment, as I told you, it's going to come up with the replica set. This replica set does the same functionality of replication controllers. So deployments, if you want to use it, you can use it because it will record it, it will maintain the as such, so that you can do the rollout, rollout or rollback or whatever you want. Daemon sets, it's going to deploy the pod in each of the node, or each of the node that you have in your Kubernetes cluster. So jobs, why jobs in the first place? Because when you have n number of pods, n number of workloads to create the create the pods, why do you want jobs? Because sometimes you'll have a scenario where you'll have to destroy the pods as soon as your functionality is complete. Some utility which you need to run only for 2 days, what you can do is, like, once the job is done, that pod will be deleted. So during such scenarios, you can create the pods using this jobs workload. So these are the important terms, or terms that you'll have to know when you manage a Kubernetes cluster. So similar to that, you have services. So everything can be offered here. Then why do you have to have a concept called services? Because um, pods are mortal. So that's the main reason we are going for services, because pods can be deleted anytime. But your internal communication between the utilities, say for example, you have like 8 to 9 services, microservices, then how will that services communicate with each other? The service discovery, how does that happen? So everything happens via these services. So services, it has all the specifications here. So if you could see the cluster IP or all the specifications that your application needs, you can specify it here, and then the service discovery actually happens. All the details are made available on a high level in the UI itself. If you want to see the actual file that you have written, you can just go to that edit section and find it. So this is much about the Kubernetes dashboard UI. So moving ahead,
So we have 10 more minutes, Karthik.
I'll quick, yeah. So supported containers. Docker is the container which is extensively supported and used by Kubernetes, but some people use RKT experimentally. But I haven't tried RKT at all because we are using Docker. So I'm not sure how that behaves. But I've heard that RKT also performs well with Kubernetes. But I would suggest, because we have the experience of using Docker, so I would suggest go ahead with the Docker containers. So the naming conventions that I told you, I think I pretty much covered everything over here, except for PV and PVC. As I told you, PV is nothing but the persistent volume, and PVC is nothing but the persistent volume claims. So you can define the storage for your specific node or the application, and each of the specification is made available in persistent volume. This persistent volume is administered only by the administrator. Persistent volume claim is nothing but the claim that you're making to the volume itself. Say for example, you have a utility or a service or a microservice. If you know your microservice is going to demand so much of storage, then you can make a claim to the persistent volume. So this persistent volume claim is in turn going to make a claim to this persistent volume and get the feature. So these are the conventions that you'll have to know when you're trying to use Kubernetes. And security, as I told you, the Kubernetes now offers RBAC. Prior to that, it was offering ABAC model, but most of them are when you are starting to use version 1.7.0 onwards, you're no longer able to use ABAC model. You'll have to strictly go with RBAC model, the role based access control authentication mechanism. As I told you earlier, you can provide roles for each and every individual engineers that are going to work with your cluster. It can be a cluster role, or it can be a role specific to the namespace, or it can be a role specific to a specific resource. Say for example, you want a developer to access a specific replication, the replication controllers in a specific namespace. You can have that role assigned, and that role can be bound to a specific user. So you can handle the security for each and every project when you are sharing the cluster for a number of projects. So there are a lot of features like this with respect to security that you can adopt with Kubernetes. So the next one is the logging. As I told you earlier, fluently you can use it to um, get the application logs, and you can use it to collect the node level logging and the cluster level logging as well. So you'll have to do a log rotation policy, because the log rotation is not maintained, or log rotation is not implemented by Kubernetes as such. So you'll have to maintain a log rotation policy, because otherwise you'll end up using all your nodes just to store the logs alone. Kubernetes stores the logs only for one day. Like, say for example, if you have all the master components, API server, kube controller, cloud controller, everything writes to a specific log. API server writes to a API server log, kube controller writes to a controller log, cloud controller writes to a cloud controller dot log. Similarly, there is a sys log. All these logs are made available in the under the log section of your instance, but you'll have to be very very careful, because it is going to store only for one day. If you want anything, you'll have to come up with a cloud tool for logging, or you'll have to have a proper log rotation policy, or anything like that. So you'll have to be very very careful, and that logging agent pod is going to write to the logging backend, from which you can adopt the logging tool that you're going to use. We are using Sumo Logic these days to pump the application logs to find out what is going on with the application, because when you have like hundreds and thousands of containers, it is very very difficult to maintain the logs. So we implemented Sumo Logic so that we can have all the application logs pumped to the Sumo Logic cloud section, and then retrieve the data from there. So monitoring stuff. Monitoring is also very important, because your cluster may come to a state where there may not be enough resources. So it is very very important to monitor the metrics of your cluster. So it's an add-on that you can implement to fetch all the metrics that you have, all the metrics from your cluster. So we are using a monitoring tool called Wavefront. It's a cloud monitoring tool. What we do is, like, we pump all the metrics from the nodes and the cluster to the Wavefront cloud, and we leverage the data from there. So we have alerts set up, so that if there is something which goes beyond the required threshold, it's going to alert us via Slack. So that is the mechanism that we have implemented. So if I could explain this in the diagram here, the hipster is going to hit each of the kubelet to get the entire metrics, and it's going to store it in the storage pod, from which you can retrieve all your metrics that the cluster uses. Coming to the case for Kubernetes, I would simply suggest you can go ahead with Kubernetes if you're adopting container technology, because if you are going to use container technology for your production environment, it is very very difficult to maintain your production environment without Kubernetes, even if it is going to be a small application. So it is very difficult to find where the container is going to lie, how the container is maintained, when there is a change in the network configuration, how can you manage. If somebody is going to come in new to your team, then it is very difficult to explain him. So Kubernetes, it's not like that. It's very very flexible. It has a very good support community. Every day there are a lot of features that are being implemented. So I would say Kubernetes is the best way to orchestrate your container technology. I think you can get started now. Maybe you can go ahead and try this MiniCube. I've just shared the links wherein you can go ahead and install the MiniCube in your laptops and start working on them. So only when you start working, you can understand what behaves like, how can you leverage that for your project and other stuff. So you can get started using these links that I provided here. And if you have any questions, I'll be able to take it now.
Good. Karthik, if you go to the other live stream, there's a live chat there,
Sure, just a
and you'll be able
second.
to see the questions. There's no questions as of yet. There may be some questions, but people are already answering the questions themselves.
Okay. So I'm in the group chat. I don't see any other
Not in the group
questions.
chat, the YouTube live streaming one.
Okay, I'll just click on that. Yeah.
Yep.
Okay.
There'll also be like, I think, a few
Okay.
seconds delay between the time you speak and people hear it there as well.
Okay.
Okay,
I don't know where to start. So if somebody is there, maybe you can speak up.
go to the bottom. I think all the questions have been answered. But go to the bottom, please.
Okay. Yeah. Yeah.
You might have to stop sharing, then you won't see this tile.
Oh. Yeah. Stop
Good,
sharing.
great.
So
Any more
yeah, so
questions?
to automate the cube deployments, you will have to use the YAML file. So everything is deployed via YAML file, be it the replication controller or the deployment or the daemon set or whatever you're going to use, the persistent volume or RBAC roles that you're going to use for your cluster. Everything is done via YAML files. So that is one of the caveat, because YAML files, sometimes when you miss one of the space allocation, then it's going to throw error. It's very difficult to find what went wrong, so you'll have to end up debugging for a long time. So but YAML files, yeah, those are the files that are being used for this Kubernetes deployments.
Any more questions? It's 7 o'clock now.
Yeah. Okay, thank you so much, Balaji. If you have
Yeah,
any questions, I'll be able to take it in the
yeah,
group. Yeah,
yeah.
and then the
Please,
meetup
please
group. Yeah,
put it in the meetup group on
yeah,
the channel, and we can watch it. And
yeah.
so next week we will continue, isn't it? About next month we'll continue the second
Yeah,
part of the
I'll come up
session.
with the demo. Yeah, I'll explain it with the
Okay.
real-time application. Yeah.
There's one more question, last minute question from Kaliswaran Kalimuttu.
Yeah, can you please explain Pod Master? So Pod Master, it is no longer being used. Um, Earlier it was used by Kubernetes master to maintain uh, maintain the leader elect and all the activities that the master is going to perform, but it is no longer being used since 1.5, I believe. I don't remember the exact version from which podmaster was removed, but I put it there because earlier it was being used, because people who have been using Kubernetes for a long time might know that. That's why I put it there. And for some reason it is not removed from the Kubernetes documentation page itself. So that's the main reason I put it in the slide.
Great. Yeah, we have
Security.
expectations for the next
Yeah,
meetup.
so
Okay. Yeah, hopefully we'll cover that in the next few sessions.
sure, Balaji. Yeah.
Right. Yeah, thanks very much, Karthik, and thanks everyone for joining to the online meetup, the live stream. Sorry for the confusion earlier. And somehow it lost that the streaming option, and we had to put a new URL for it. And next month we are also probably we might get the AssureCorp guys from the UK to talk about one of their content as well. But we'll confirm that in the next few weeks. Thanks very much, everyone, and have a good weekend. Enjoy the rain and enjoy the Saturday and Sunday. Thanks, Karthik. It was
Thanks, Balaji.
fantastic. Thank
Thank
you.
you everyone for joining us. Thank you. Have a great weekend. Bye.
Thank you. Bye.